We're going to be looking at now some examples of some of the that's based on some of the vocab we'd covered in the previous video. The first question asks, rewrite the following functions in a factored, there's just one, should be function, in factored form. Write any repeated factors in exponential form, name all the zeros and their multiplicity. So the first thing we need to do is factor all these terms. Factor all these expressions. 2x squared minus x minus 3. This can get broken down. If I'm going to factor by grouping, 2 times negative 3 is negative 6. Factors of negative 6 add together give you negative 1 or negative 3 and 2. We can rewrite this as 2x squared plus 2x minus 3x minus 3. We'll group. Pull out what's common. In this case, 2x times x plus 1 minus 3 times x plus 1. What we're left with is 2x minus 3 times x plus 1. That's coming from that 2x squared minus x minus 3. We can factor this next term. This one looks easy enough to do by guess and check. Looks like there's going to be an x here, x here. One's got to be positive, one's got to be negative. One of these, the factors of negative 4 that add together give you negative 3, negative 4, and positive 1. We'll bring this back down. X plus 1, x minus 4. And finally, our last term, x minus 4 brick, gets brought down as well. I got to play a little around the world to get it there, but it looks okay. So when we look at our expression in final factored form, we see that a couple of our factors are repeated. 2x minus 3 is okay, but x plus 1 gets repeated twice. We can write that in exponential form. And x minus 4 gets repeated twice. So we've taken care of that. Write any repeated factors in exponential form. Name all the zeros. Their zeros are solving 2x minus 3 equal to 0. You get x equals 3 halves, x equals negative 1, and x equals 4. For us asking for the multiplicity, we have to see which ones have been repeated more than once. In this case, it's negative 1, positive 4. Both have a multiplicity of 2. Take that heading, maybe move it up. Again, both of those have multiplicity 2 because their exponents on the factors is 2. This is kind of a basic problem, ones that you'll be able to factor. In the next few days we're going to be looking at ones that aren't easily factorable right from the beginning. But it's good practice because we're going to have to use those skills throughout this section. Next question says, find an equation with degree 4 and zeros of x equals 3, x equals 3i, and x equals 2. I'm going to start with just our real solutions, x equals 3 and x equals 2. When I'm building this, we'll just call it, I don't know, f of x for some function. The first zero will be x minus 3. Because the second zero is x minus 2, our next factor will be x plus 2. We can do the same thing with x minus 3i, but this is kind of giving us more information than we maybe would expect. It's telling us that if x equals 3i, we also know, because complex solutions come in conjugate pairs, that negative 3i is also a factor. So we can also put in x plus 3i. The reason why is in order to get this I, what I'm doing is taking the square root of negative 1. Or the equation we're setting up is x squared equals negative 9. When we take the square root, we get x equals positive 3i, which is where this solution would be coming from, but we also are having, because we took the square root, a positive negative. That's why complex solutions always come in conjugate pairs. If you've got the positive, you also need the negative. In order to write this, we kind of have to show a polynomial in standard form. So we're going to expand this using FOIL, and we'll get x squared minus x minus 6 times, when you multiply those two together, you get x squared plus 9. I know that may be a bit of a reach, but if you FOIL it out, it all comes through. The next thing we're going to do is expand this, distribute my x squared to get x to the 4th plus 9x squared. Distribute my negative x to get negative x cubed minus 9x, distribute by negative 6, to get negative 6x squared minus 54. We have a few terms we can combine, but our final solution becomes x to the fourth plus, minus x cubed plus 3x squared minus 9x minus 54. And there's our final solution.